Hello everyone, my name is Zhang Shuhan, and now I will introduce the method that I use to solve the question 1 on homework 11. The question 1 gives us that the xt is real white-side stationary process with autocorrelation Rxx tau and power spectral Sx omega. The first question is to prove that the autocorrelation is real and even. First, we apply the definition of autocorrelation functions, which is the expectation of x t plus tau times the xt. And this is real because xt is real, and there is no complex part in these equations. Then we need to prove the autocorrelation is even. First, we apply the autocorrelation equations and we write this like this. The first input is t plus tau and the second input is t. And we write the expectation functions and we exchange the position of these two parts. Because it's a multiply process, we can change the order of each part in these equations. And then we can write these functions back as the autocorrelation, which the first input is t and the second input is t plus tau. And this is the autocorrelation with the minus tau. So the autocorrelation tau is equals to the autocorrelation of minus tau, which means the autocorrelation is even. And the next part, we need to prove that the power spectral S omega is even and non-negative. First, we consider that first we need to prove that this equations is even. And we apply the Fourier transform to the autocorrelation, and we get the power spectral S omega, which is like this. And we use the Euler formula to transfer the e to the power of minus j omega tau to cosine omega tau minus j sine omega tau. And we can write this integral in these two parts. First, we focus on the second part. As we proved above on question A, the autocorrelation functions R tau is even and the sine functions omega tau is odd. So the product of these two equations is odd. So that the integral of a symmetric area of odd functions should equals to 0. So there is only the first part remain in these functions. And then we also consider that the cosine functions is a even functions, and the autocorrelation R tau is also even. So we can write this functions like this. In order to prove the power spectral S omega equals to power functions of minus x omega, S omega, we need to consider these two parts respectively. First, the autocorrelation functions is even and the cosine functions is even. So we can substitute the tau with minus tau to this integral, and we get the solutions that the power spectrum functions is also even. And next, we are going to talk about whether the power spectral functions is non-negative or not. First, let's consider this. Let's consider a system with the system transfer functions is a bandpass system, and bandwidth is from omega 1 to omega 2, and we need to find the expectation of big YT square. First, the YT square is larger than 0 and is smaller than the is larger than 0, and the system power should equals to the integral of this, and the h omega is larger than 0, is equals to 1 at the from the range of omega 1 to omega 2, so we can write these integrals like this, and this integral should be larger than 1 at everywhere, so and the power spectral S omega is non-negative at everywhere. That's all. Thank you.